Impact of climate change on the nutritive value of dietary components of ruminants in Central Europe. As a general background, climate change impact on global crop production. According to the World Meteorological Organization report of 2018, the global temperature of the 5 years average is the highest 5 years average in record. The world's 9 warmest years have all occurred since 2005 and the 5 warmest since 2010. The report further stated that the start of 2018 has continued with extreme weather, unusually high temperature, bitter cold and damaging winter storms, extreme heat waves, continued drought and acute water shortage across the globe. These changes in climatic conditions altering crop cultivation practice in many areas of the world. According to the Intergovernmental Panel Discussion for Climate Change 2014 report, the loss in crop yield or crop production will be severe when we reach to the end of the century, particularly between 2019 and 2100. When we take as a single crop, for example, the effect of climate change on corn crop production, climate change will increase the risk of corn crop failure across the world's biggest corn growing regions. In this report states that if the global warming maintain 2 degrees Celsius or below at the end of the century, and this is the Paris climate change protocol to maintain the global warming below 2 degrees Celsius. The US corn production will be reduced by 17.8%, but if the global warming raised to 4 degrees Celsius at the end of the century, it could cut the US production almost by, the US corn production almost by 50% or 46.5%. But the recent report of the United Nations in the Governmental Panel Discussion 2018 states that the global warming is likely to reach 1.5 degrees Celsius between 2030 and 2052. And majority of the predicted damaging effect of the global warming at 2 degrees Celsius is likely to happen at 1.5 degree marks in between 2030 and 2052. So based on this, nowadays interest is increasing for alternative feed crops, even though reports are very limited. Finding acceptable alternative forage to replace full crop corn silage is a difficult task because of the very high competitive advantage of corn silage, like its high digestibility, higher energy values, and high fermentable characteristics and other related values. So in this regard, the last 20 years, experimental studies were conducted to replace whole crop corn silage, taking into consideration the global effect of climate change on corn production, such as using whole crop triticale silage, annual ryegrass silage, and perennial ryegrass silage, whole crop rice silage, Italian ryegrass silage, different forage millet cultivars, alfalfa silage, whole crop sorghum silage, high sugar forage sorghum silage, as well as wheat and triticale silage. But all the studies reported their limitation in attempts to replace whole crop corn silage. So when you come to the specific situation in Hungary, the expected weather condition in Hungary, in line with the global trends, Hungary has also observed the major changes in its regional climatic condition in the last 100 years, and more intensely in the past 30 years. According to the Hungarian Meteorological Service, an increase more than 1.2 degrees Celsius in average can be observed in the mean annual temperature since the early 80s in Hungary. In addition to this, a considerable change in intensity of temperature extremes can be observed as well. The decrease in the number of frost days and the increase in the number of hot days clearly shows an accelerated warming phenomenon in the country. When we see, according to the climatic models, indices of extreme temperatures in the summer will increase in the future. The annual mean temperature will increase by 1 to 2.5 degrees Celsius in 2021 to 2050 period, while the degree of warming will reach 2.2 to 5 degrees Celsius by 2071 to the end of the century. Temperatures will be 6 degrees Celsius warmer on an average in the distant future mixture, especially in the southeastern parts of Hungary, which shows the consequences of climate change are territorially differentiated. The expected precipitation is also similar. For example, when we see in between 2021 and 2050, the amount of precipitation in the summer period will be -5 to 10% in between 2021 to 2050, but it will be more decreased further to 20% in between 2071 to the end of the century. Forages in dairy rations. Before 15 years, the Hungarian forage production is based on corn silage and alfalfa hay and haylage, and the remaining is composed of other nutrients or components. But nowadays, such composition of forage took a kind of paradigm shift in order to replace the corn silage and alfalfa haylage with other alternative crop silage. For instance, using early and late harvest annual cereal silage, as well as sorghum silage and Italian ryegrass silage. So when you see the evolution of forage base in Hungary for the dairy cows, in 2017 it was entirely based on Italian ryegrass to replace the existing forage system, which is the corn silage and alfalfa haylage. But in 2012, early harvested rye came after, and in 2030, early harvested triticale was also introduced in the system. In 2016, sorghum and Sudan grass was also introduced in the system. And in 2017, Fistulilium is also introduced in the system. And finally, in 2018, Italian ryegrass and winter cereal mixtures are introduced in the feeding system to replace partly the corn silage and alfalfa hay and haylage composition in the total mixed ration. Now, the very research question is why Italian ryegrass and winter cereal mixtures? Italian ryegrass, both in its fresh and preserved form, is frequently used as a forage for dairy cows and known as a high energy value and high digestible fiber forage. It has an elevated concentration of water-soluble carbohydrate. It's also known as high sugar grasses. The high water-soluble carbohydrate improves the balance and synchrony of nitrogen and energy supply to the rumen. And the grass species has also high crude protein as well as high net energy content. And the energy concentration, the high energy concentration, is due to good nutrient digestibility, can be explained by relatively low lignin content of the grass species. But we don't have any further information so far how this mixture is going to be planted, or we don't have any information on seeding two or more winter cereal, as well as Italian ryegrass and winter cereal mixtures. But we formulate the following advantage of seeding Italian ryegrass and winter cereals from the agronomic point of view. It increases both grain and forage biomass yield. It allows double cropping so that two biomass can be harvested per year. It reduces soil erosion and maintains the environment, increase the probability of crop survival at the time of weather extreme. It also important for sustainable farming that the components of the mixtures react differently to the amount of rainfall. From the production or economic point of view, two mixtures can be seeded to complete the nutrient deficiency in a total mixed ration. It also reduces the cost of concentrate, increase overall productivity, product quality, improve the net return of productivity, and maintain the rumen environment, consequently increase the digestibility and or the in situ ruminal degradation kinetics as well as ruminal fermentation process. So in the Hungarian University of Agriculture and Life Science, for the last 4 years, we conducted 2 different experiments at different phases on the use of Italian ryegrass and winter cereal mixture with following objectives: to evaluate the nutritional composition, fermentation characteristics, and microbial quality, aroma profile, ruminal degradability, ruminal fermentation, and to evaluate the net energy content of the inside mixture. Experiment 1, material and methods. The trial was carried out on the large scale farm with 2 mixtures composed of Italian ryegrass and winter cereal mixture. Cutting was carried out in the heading stage of triticale at 10 centimeters double head. Wilted and chopped materials of 510 grams were packed by hand into a laboratory cellulose, total number of 30, 50 per each mixtures, and stored in a controlled laboratory. The chemical analysis of both fresh and inside mixture were done following the AOC 2006 and the ones was the 1991 protocol. Approximately 25 grams of sample, composite sample was taken from each laboratory silo at the 3 opening days, 7, 14, and 19. pH, the lactate, the volatile fatty acid and ethanol, aerobic mesophilic microbial count as well as mold and yeast count was done following the standard protocols for each. After the 90 days fermentation, the inside mixture was subjected to ruminal degradability study. Cows were consumed a total mixed ration with 9.12 kg of dry matter and 6.32 megajoule net energy per lactation per kilogram per day. Nylon bags of 5 times 10 cm with a pore size of 53 micron, filled with a sample weight of 5 grams, was incubated for 0, 2, 4, 8, 16, 24, 48, and 72 hours incubation times. The Nilin program in SAS used to calculate the values of A, B, C, D, A, B, and C fraction. The digestibility study was conducted using 6 with the Hungarian merino sheep, individual metabolic kits that gave them access to water, 10 days adaptation period followed by 5 days complete feces collection, 1.4 kilogram dry matter intake per day, plus 30 gram mineral and vitamin premixes and 10 gram of sodium chloride. Feed intake, feed refusal, fecal output were recorded daily during the collection period. Data were analyzed using the GLM procedure of ANOVA in SAS 9.1 software. The net energy for lactation, the net energy for maintenance, the net energy for gain was calculated following the equation 212, 213, and 214 of the National Research Council 2001 protocol. The result shows that the dry matter and crude protein content of mixture B was higher than mixture A. This could be due to high inclusion of Italian ryegrass in mixture B, particularly the Italian ryegrass contain high crude protein content. That's why the crude protein and the dry matter content was higher for the more Italian ryegrass mixtures. But when we see the fiber fraction, it is lower and better for mixture ACLH, which has only 40% Italian ryegrass and 60% winter cereal mixture. The low fiber content or the low fiber fractions of mixture A is due to efficient fermentation with a pH low and high lactic acid content. The acetic acid was also higher for mixture ACLH. Otherwise, there is no any significant difference on lactic acid to acetic acid ratio of both mixtures. The microbial quality states that both aerobic mesophilic bacterial count and mold and yeast count has no any significant difference at the 3 opening days for the 2 mixtures, except at day 19 for mold and yeast count. When you come to the ruminal degradability study, the effective dry matter, effective crude protein, the potential degradability NDF and potential degradable ADF fraction, there is no any significant difference between the 2 mixtures. However, the effective protein degradability as well as the potential degradable NDF and ADF fraction was higher, which could improve the feed intake and the digestibility or ruminal degradability of the inside the mixture. When you come to the digestibility study, the inside the mixture, which is mixture A, composed of 42% Italian ryegrass and 60% winter cereal, had high crude protein as well as high nutrient detergent, neutral detergent fiber, and acid detergent fiber digestibility. When you come to the energy evaluation, all the net energy for lactation, net energy maintenance, and net energy for gain of the inside the mixture was higher than all the values of alfalfa silage, grass, and winter cereal silage, which was reported by the NRC 2001. However, the inside mixture had still lower values of net energy for lactation maintenance and gain as compared to corn silage. Conclusion and recommendation: with proper stage of harvesting, Italian ryegrass and winter cereal mixtures were wet fermented. The high potentially degradable fiber fraction in mixture applied in the diet may increase the diet and give rumen degradability, having positive effect on the dry matter intake. The apparent nutrient digestibility of all the nutrients was above 67%, and the high-end digestibility improved the net energy concentration of inside the mixtures. The inclusion of 40% Italian ryegrass in a cereal mixtures provide well-fermented silage with excellent feed value. The mixtures are autumnal planting and yearly harvested forage, therefore it can be well integrated into crop rotation. Double cropping can also be done with short-growing corn combined with sorghum and Sudan grass. Study 2. In the second study, on second trial, we use two purely winter cereal mixtures, 100%, and two Italian ryegrass and winter cereal mixture with the same proportions as described above. In this phase, we also study the Roman fermentability of the four inside the mixtures by replacing 3.5 kg per day of veg and triticale hay in a controlled diet which was prepared based on the NRC 2001 protocols. Therefore, 3.5 kg of veg and triticale haylage was replaced by mixture A silage, mixture B silage, mixture C silage, and mixture D silage in experimental diet 1, 2, 3, and 4, and the control diet is used as control treatment. The aromatic profile of the inside mixture was also studied in this phase. Sample from the fresh green forage and from each opening 7, 14, and 19 days were frozen, and a total number of 80 samples, 20 per treatment was taken. Frozen samples were taught and chopped with scissors. The small fingerprints of the silage samples were acquired in 3 replicates by measuring 3 times. The electronic node measurement was performed using Heracles Neo 300 ultra-fast gas chromatography analyzers, specifically designed for rapid analysis of volatile compounds. The result shows that after 19 days of fermentation, the inside the mixture A, B, and C and D had higher pH content. This could be due to lower lactic acid production. The main reason for such kind of fermentation is the produced excessive total sugar, which shows that this kind of fermentation undergoes restricted fermentation process. This restricted fermentation was happening when the epiphytic yeast converted excessive sugar into high proportion of ethanol. You can see the inside the mixture contains high proportions of ethanol, even though there is no any significant difference between the inside the mixtures on the ethanol content. The mold, the microbial and mold and yeast count of the inside the mixture after 90 days reveals that mixture C has the highest mold and yeast counts and mixture B silage. The Roman fermentation study revealed that there is no any significant difference between control diet and experimental diets at 0 hour and 6 hours after feeding sampling, whereas at 3 hours there is a significant difference on the ammonium nitrogen as well as the butyrate concentrates of the inside the mixtures. Consequently, experimental diet 1 has the highest ammonium nitrogen and experimental diet 4 has had the highest butyrate concentration as compared to other experimental diets. Fermentation characteristics of inside mixture described by electronic nose. In the knowledge-driven phase, we try to analyze the fermentation characteristics of the inside mixture using an electronic nose. And the result shows that the electronic nose is quite sensitive to ethanol as compared to acetic acid and lactic. Due to this, the ethanol shows the highest peak here, you can see from the picture. But when you see the zoomed image, we can see there is no any significant difference between the ethanol content of the inside mixture, which is exactly coincides or similar to our experimental, or statistical analysis so far. But you can still see the small peaks of lactic acid and acetic acid in the zoomed image. The principal component analysis score plot of the aroma profile of all mixture revealed that at day 0, there is no any differences on the aromatic profile of the inside the mixtures. At day 7, it starts to be a little bit separated to each other, but still there is no significant difference between the 4 mixtures at day 7 and day 14. But at day 19, you can see clear separations among the inside the mixture, with mixture D is totally separated from the other mixtures. When you see the principal component analysis for mixture A, B, C, and D silage at different opening days, you can still see there is a separation or differences at day 19 for all inside mixtures as compared to the other opening days. Conclusion and recommendation. The inclusion of 40 to 55% Italian regress did not cause any significant quality advantage on purely 100% winter cereal silage. The restricted fermentation affects the output of fermentation products such as moderate lactic acid and higher ethanol content. The use of silage additives to improve aerobic stability of silage is recommended in future practical use. The replacement of inside mixture with vetch and triticale hay in total mixed duration did not cause any deleterious effects on the Roman environment. The restricted fermentation had mixed effects on the Italian regress plus winter cereal mixture silage on aromatic quality. Due to the presence of higher ethanol and lactic acid, mixture D shows its richness in aromatic quality. However, the high mold in yeast count, together with low lactic acid and ethanol contents, cause some off-odor compounds in mixture C, which could affect its feed intake. The pure winter cereal mixture had similar aromatic pattern, but its richness is lower than mixture D silage. Electronic notes could be practically useful rapid analytical technology to characterize fermentation, identify and quantify of the most abundant volatile components of silage, giving a good description of sensible smell. Electronic nose also gives the possibility to identify the characteristics of false fermentation process